Thank you very much for dialing in. My name is Ricky, and I'm a co-founder of Data Mastery along with Ken. And I have been like around 20 years of experience in IT, more focused on cloud and data-related architectures and building, platform architecture for dev teams and business analysts and machine learning engineers. So more of kind of stitching all these platforms together. That's my day-to-day job. In today's session, we're going to talk about building Gen AI workflow using Amazon Bedrock. So we are going to start with what is Amazon Bedrock. So if you have worked with AWS and probably into Gen AI, you probably know what is Bedrock and it's what kind of features it has to offer uh, for people who are into building Gen AI platforms. Yes. So just a quick overview. Bedrock is a fully managed service that provides access to foundational models from multiple AI providers like Anthropic, Llama, and you also have the new models that came in recently like Neo Lite, Neo Pro. So it has you can say a catalog of foundation models that you can use right within Bedrock without doing any heavy lifting. It's totally serverless and API driven, which means you don't have to manage any infrastructure for this. And you can use APIs to make calls to Bedrock from your apps or from your scripts. So it supports APIs as well. You can fine tune the existing foundation models, and you can also import the models which are not there in the catalog of foundation models. So for example, if you have a model like DeepSeek, which you don't see there, or any other model which you see on the Hugging Face, library, which is not there in the Amazon Bedrock catalog, you can import those models as well. And you can also do the fine tuning for your existing models. And also you can do the, set up the workflow using RAG. For the RAG workflows, you can use service like knowledge base, which we'll touch base in a moment. Like I said earlier, you can import the custom models, which you don't see in the Bedrock catalog. Use cases, most of the industry, what they are doing with AI in general and not specific to Bedrock is building chatbots. For example, organizations have tons of data internally, and that's what they want to use with the AI, and you can get some insights from your internal data. Or if you set up, let's say, a call center, which majority of the organization, for example, which are in the insurance sector, so they have these call centers set up. So you can set up a chatbot for your the voice as well as the text-based bots which act as agents. You can generate content based on your existing data or based on the public information which the foundational models has. ChatGPT is the prime example, but you can also generate content based on your private data. For example, if you are a legal firm and you have tons of data, which is kind of the legal contracts, which is not able to understand normally using those legal language. You can use the summarization of those legal contracts to make it easy to understand. Plus, based on the existing data, you can also generate new data from your private data sets. There is a feature called prompt templates. Now we're going to touch base some of the features which are specific to Bedrock. The previous slide was more of the generic high level understanding of Bedrock, which more or less what most of the service providers offer. But prompt template, for example, or just the prompts or the templates, this is specific to Bedrock. Now, what is a prompt template or prompts? It's a library of prompts. So what it allows you to do is to create your templates, prompt templates, and you can create the version of your prompt template, just like you can create the version of your code. And you can just build one template in your application and see if it's working fine or not. If you need to refine that template, you can create a new version of that, and you can point your application to the new version of the prompt. So that's where something called prompt engineering, which comes pretty handy. So you need to understand, or you need to know how the prompt engineering works, or how you can write a good prompt template. That is very crucial for getting the accurate response from your AI models. Like I said earlier, you can create multiple versions of the prompt, and this also helps you to fall back on the previous version. Let's say you create a new version and your application is not behaving as expected. What you can do is you can point your application back to the previous version, so it gives you that fallback option as well. You can create dynamic prompts using variables. So you don't have to just write a static prompt and use that throughout your workflow, but you can make it more dynamic by replacing your variables with the input that comes from the real-time workflow input. For example, if a user input something, so some of the variables are location, for example. So location can be captured as a dynamic variable, and rest of the prompt can be static. So that way you can cater to multiple locations versus defining location as a static value in your prompt. So this is one example of a well-written prompt. Like you have instructions for system, and you can basically, provide all the context here, like your AI-powered customer service assistant, and whatever you want your model to respond, or whatever type of application you're building, you have to write that very clear template. And you can also provide example of how the user message is going to look like. So this will provide more context to the model to understand, okay, what exactly I'm responsible for and what type of messages I can receive from the user. And based on that, you will get very, accurate and very to the point response from the model. And you see this order number in the double curly braces. This is what makes it a variable. So instead of putting order number as a static entry, you can put this into these curly braces. That way, whatever the order number that will be passed by the user in the input, that value will be replaced here in the prompt. So this is how you can make your prompts more dynamic in nature. The other feature of Amazon Bedrock is knowledge bases. So knowledge bases allows you to build a RAG workflow. So you can build it into, like before Bedrock, you had something called Amazon Kendra, sorry. So Amazon Kendra allows you to look into your data sources and get the top, let's say, top documents which matches with your query. And then you can take those top documents from your data source and feed into Bedrock and then get the, response based on those documents. So what knowledge bases does, what Amazon does with the knowledge bases is that they added the support for Kendra right into knowledge bases. And they also added support for other, you can say, vector store databases, like OpenSearch is already there, but you can use RDS, and you can use even your MySQL, which is not hosted on RDS or Pinecone. So there are some other vector store databases that knowledge bases support. So it allows you to build end-to-end RAG workflow, and which is again fully managed service. It supports multiple data sources. Obviously, it's an AWS service, so it does support support for S3 as a data store, but it also supports the third-party tools like ServiceNow or Confluence, so where or SharePoint, where you have most of the companies have their data stored in. It could be the wiki pages, or whatever the knowledge base articles that you have written there. So you can hook up those third-party providers right into knowledge bases and start getting the data from there. It does support both structured and unstructured data. So structured data means you have data which is, let's say, in the CSV format, or you can point this to your RDBMS databases, so where the data is more structured. Plus, it also supports unstructured data, like you have some PDF documents or your wiki articles. So those can also be supported with knowledge bases. This is one very high-level workflow on how these kind of the RAG workflow works in general, not specific to knowledge bases. So on the left, you see a data source, which is S3 in this case, but this could be any data source. But what happens, in the middle is we get the data from the data source, and the data is then divided into the chunks, which means a sentence of whatever the data, like the bigger sentences are split into the small segments of data, which is called data chunks, and then we convert those uh, data chunks into numbers, and which is what embeddings does. And then you have to have embedding model to convert those the data into the numerical format and then store them into the vector database. Now, this could be OpenSearch or Pinecone or whatever the suitable vector database. This is what happens when you show the model your private data and you create the vector database. Now, when a user comes in to query the data from your private data source, the input data from the user also gets split into embeddings, and then those embeddings are basically matched with the embeddings that we store in the vector database, and that's how you get the more relevant information from the vector database. And then those embeddings are basically converted back into the text format, and then you get the response from the model. So we have embedding models like Amazon Titan, and then we have the language models like Claude or Neo. So all those are language models which generates the text, and embedding models are basically which takes your data and convert into the numerical format. The another feature of Amazon Bedrock, and this is very kind of a feature that helps you to build your end-to-end Gen AI workflow, not specific to only RAG workflows, but whatever workflow that you're gonna use or build in Bedrock. So it allows you to orchestrate various components, agents, prompts, knowledge bases. So we talked about prompts, which is basically creating your prompt templates and building up a prompt library. And then you have a knowledge bases, which is more of your workflow. Then you have agents, which we're going to talk about, when we do the demo. So that's what our demo is more focused on, using like how to build the workflow using flow service or flow feature of Amazon Bedrock service. Now, what agent does is, and that's where the industry is more or less shifting towards. Most of the companies started with RAG. Okay, so now they have some sort of AI in place, so they can, summarize their data. They can generate some more content based on their existing data, but that's all about the data that you show to the model. But what if you want to do something which your model is not trained on, right? So if you want to know something in real time, like what's the weather in my city right now, so your no foundation model or no language model knows that, because like they are not able to fetch the real time information. So that's where you use agents, and agents use several APIs, and you can deploy agents with the support of Lambda, so that you can make a call to API and get the real-time information, and then that real-time information is something that you feed into your workflow. So that's what we're going to focus on in the demo as well, where we'll see how you can book a restaurant in specific city. So we just will have that high-level workflow in the demo. So when you build the flow, it's a fully UI builder. Obviously, you can use the templates as well to build the flow, but it also provides you an option to create the workflow using web interface. Again, it's fully managed and serverless. You don't have to manage any infrastructure for this. And this is one example of how flow looks like. So you have the node that you see on the left is the input node, and the node that you see on the right, these are the output nodes. So these two nodes are something that's always gonna be there. And in the middle of these nodes, you have multiple other nodes based on what type of workflow that you are going to build. Now, in this example, the input, which is basically a user input, it is received by a prompt node, which takes that input, and then in the prompt node, we actually have a well-defined prompt. You can define a prompt in the node itself, or you can pull the prompt from the prompt template library, and we will see in the demo. And then you can pass the output of your prompt into this conditional node, and based on this condition, you will get the output, which is going to be displayed by these output nodes. So this is how a workflow looks like when you build that in using the flows feature of Bedrock. In this demo, what we want to do is we are going to build a conversational workflow using Amazon Bedrock. There is a feature which Amazon, uh, which AWS basically recently announced, and that is a multi-turn conversation for the agents, and that support has been added into the flow service as well. But that's still in preview, but that's what we're going to focus on. We will see how you can build a prompt, how you can set up the agent, and how you can build end-to-end workflow using agents and prompts. So let's get started with the, the demo. So I'm just going to stop sharing this one, and I'm going to start sharing my other screen with AWS account. Okay, so now I'm logged into my AWS account, and this is where we're going to see how to build this workflow. But before that, I'm just going to also touch base on to these services, what we just talked about in the presentation. So first thing that you need to do is to go to your Bedrock service. And what I'm going to do now is I'm going to start with agent, and I'll explain like what this agent is doing. And from there, we will go backwards and try to do the reverse engineering and see what different components are basically, we have configured and how they are configured in order for this agent to work as it's working right now. So I have an agent here, which is called a restaurant reservation agent. So when you build an agent, it also gives you a nice testing a playground right in the console. This agent is supposed to book a restaurant for you, but it also makes sure that you provide all the information that this agent is expecting for you to provide. Now, how does that happen? That's what the multi-turn conversation feature is in the agent. So if I ask this agent that, can you book me a restaurant in Toronto on March 31st. So this is what I'm asking my agent. Now, the agent is asking me some additional detail. Now, usually this is not something which is common because agents are not kind of come back and ask you, but why this is happening, we will see like why the agent is asking for additional information. So what the agent is asking me to do is saying, okay, can you provide the number of guests, cuisine preference, desired time, and restaurant name? So let's say there will be 6 guests, um, and preferred cuisine is Italian. The preferred time is 5 p.m. and restaurant name is, let's say, La Italia. Like it's a made-up name. So you pass this information to your agent, and then it will process this. Now, why this is asking for these questions? So you can click on Edit in Agent Builder, and you will see something called action groups. So when we create action groups in the agents, what we do here is we create something called parameters. So we specify these required parameters, for example, date, guest, cuisine, location, time, restaurant name. So these are all required parameters. And when you pass a query to the agent, and if the agent does not see any of these parameters or information specific to, let's say, number of guests or cuisine or location, it asks you for that information. So that's where like it's a concept called multi-turn. So it comes back to you and asks you the information. And the other action group that you can build is, okay, once you get the information, how you can create a reservation, right? So you can create a separate action group called create reservation. And this is where you can set up something like AWS Lambda. So right now, I have a Lambda which is not actually making the booking, but it's just returning the response. And it will just tell you that, okay, it's a dummy Lambda that, okay, your booking has been done and all that stuff. But in real time, you can make an actual Lambda which will actually check for whether the slot is there or not and then reserve the booking for you. Now, the action groups, if you have multiple action groups, how does the agent know which action group it's going to use? So this is where you provide the description, which helps the agent, but in general, agent is smart enough to understand which action group I have to pick based on the query. The other thing is, if I go back to my agent definition, within the agent definition, you can select the model that you want to use with this process. So you can select the model, but in case you don't have access to the model, you first need to go to this model access and get the access. And afterwards, you can use this. Now, this is very important, the instructions for the agent. So this is where you define a prompt basically. You tell the agent that, okay, you are a reservation booking agent, your role is to this and this, and once all the details are collected, you need to create and confirm the reservation. So a well-defined prompt here, obviously like this is not a very kind of a detailed prompt, but this is your chance to, create as specific prompt as you can so that you get more accurate answer from the model. The other thing, when you gonna deal with these multi-turn conversation where model is gonna come and ask you for additional information, you have to enable this memory or session summarization as well. So that will allow the agent to memorize the context. Like if I'm asking a question and the model is asking or the agent is asking me a follow-up question, it should maintain the context. Like it should not totally forget about the first question when it's asking the second question. So that's where enabling this memory feature for session summarization, that's what you need to have it enabled. So this is what you define in your agents more or less. Now there were some other pieces that we talked about. The one was called prompt management, which we can use to create the prompt library. So I have something called a travel guide, for example. What you can do is you can write a prompt and you can make it more dynamic based on these dynamic variables that you can offer here. And this is, for example, a user message, which I'm putting in here. You can also set up the temperature so that your model does not, do a lot of hallucinations and the response is more or less similar. So you can control these configurations. The one thing that is pretty cool about this is you can create multiple versions of your prompt. So this is what I was talking about earlier in the introduction. Let's say this model, this prompt is not working for you as expected. So obviously you can go ahead and refine this model or refine this prompt, and then you can create a new version of this. And if you click a new version, every new version will have its own ARN, and this is the ARN which you can use in your application. And if it doesn't work, then you can go back and switch back to the previous version. It also allows you to select the model as part of your prompt template configuration. So you don't have to find the model somewhere else. Uh, the reason for that is when you test your prompt, you test it against a model, right? So whatever the model works for you best, so you keep that model in your prompt configuration. So this is how you can define your prompt library using prompt management. The other concept that we touched on was knowledge bases. Like I explained earlier, this is what you can use to create a RAG workflow. Now, it does support Kendra right now. Previously, like when it was launched, it was only used to support the vector store databases, but now it supports Kendra Gen AI index as well. And you can also use your Redshift as a data source. So this option, which is called knowledge base with structured data store, it allows you to connect your uh, Redshift data store with your RAG workflow and get the data or the information from your Redshift data warehouse. Now, when you click on, let's say, so let's see some of the options of the, the various data sources that it has to offer. So when you select the knowledge bases with the vector store, this is what you see. You have support for S3, you have support for the web crawler. So, the web page that you want to crawl, any public web page. And there is also a custom option as well. So if you have a custom data source, this also possible to connect with a custom data source using knowledge bases. But these three ones are the Confluence, Salesforce, and SharePoint. So this is pretty neat because most of the companies have data in one of these providers, either Confluence, Salesforce, or SharePoint. So you can hook those third-party providers right into your knowledge base workflow, and then you can start getting your data from there. So let's say if I click on S3 and I click on next, I will just I'm not going to build a knowledge base workflow because our topic is different, but I'm just going to show you some of the options here, what it has to offer. So you can also use data sources into which are there in other AWS account. For example, if you have S3 bucket in some other AWS account, you can use that as well. And then there's some options about the parsing, like how you're going to parse your data. And there is also the chunking strategy, like we discussed in brief, like how the data is chunked. Like the bigger data is basically split into the smaller pieces, and it is called your data chunking. And there are like multiple options of chunking your data, multiple strategies. And this is what I wanted to show you here. So we saw that when you, once your data is basically split into, the shorter chunks of data, then you have to convert your text into numerical format. And basically that's what we call embeddings. And you have to select an embedding model here, which will convert your text into numerical format. And then where you're going to store those embeddings. So you need a vector store database. Since this is an Amazon service, it does support OpenSearch serverless, Aurora, Neptune Analytics. So, and Neptune Analytics is more for the visual data, like the graphical data. But in addition to these AWS offerings, it also supports other vector store databases like MongoDB Atlas, Pinecone, Redis Enterprise Cloud, and other are basically the same that we talked about earlier. So it does gives you a lot of flexibility in terms of data sources selection and also what kind of vector store, database that you want to use in your workflow. Now we're going to go to the main feature, which is called flows. And this is what basically whatever we have seen so far, agents, knowledge bases, prompt management, uh, all of these components can be integrated together in Flow, and that is what you can use to build an end-to-end Gen AI workflow. So I have a one called multi-turn demo, and it also supports multiple versions, by the way. Just like the prompt management, you can create multiple versions of your flow, and then you can publish your new version. So let's click on Edit in Flow Builder, and this is my workflow. So what it does, I have several options here. I have the flow input node. By the way, so all these pieces that you see here, these are called nodes. And on the left side of your screen, so these are all the nodes that is supported by a flow. It supports collector, condition, iterator, which is basically like for loops. Condition is like if else. Then you have agents and prompts. We saw that there's one agent that we have set up for reservation of a restaurant. You can call those agents in your flow. You can also call your prompts. Like I have one prompt which is for travel guide, so I can use that prompt in my workflow. You can also directly call Lambda function in your flow. You can call knowledge bases. So if you have built a RAG workflow using knowledge base and you want to put that thing into your main flow, you can use that as well. And you can directly interact with S3 and Lex as well. So Lex is basically to create the bars and all. And the final is the flow output node, which is what we use to display the output of this workflow. Now, what this workflow does in this case, I have the input. Input is where the user message is going to come from, basically, a query, a question from the user. And then that will be received by my prompt. This is my prompt node. Now, what you can do in this case is you can define the prompt template or the prompt basically within the node, like I have done here, or you can also import it from the library, so which I'll show you in a minute. So when you can click on this node and you start configuring it, you have to provide a model, right? So I'm using Novalite for this. And in case you have set up a guardrail, you can select that as well. Now, what is a guardrail? Let's say you want to eliminate some of the words which you don't want to use in your flow, some words which are not acceptable. So you can put those words and put a filter on that, and you can create a guardrail. So which means even, for example, if your document or your data has some personal information about customers and you don't want to have that personal information being displayed anywhere, so you can create a guardrail around that and use that guardrail in your workflow. For example, email ID of a customer, you don't want to show that, so you can put a guardrail and use that in your workflow. And then you can define a message here, which is a prompt basically. So you're telling your model is that your query classifier, so analyze the input and respond with the single letter. So based on the input that is coming from user as a user message, there are two options in this case. The one is the queries related to booking a restaurant, or the second information is some generic information about a city or some destination which someone wants to visit, right? A travel guide, for example. And then you can specify your inference configurations here as well. Now, the second node is after your query is being processed by the prompt node, it will provide uh, either A as an output or B as an output. So that output will be received by your condition node, and your conditional node will say that, okay, if the input is A, the input of this node is basically the output of your prompt node. So if the input of the condition node is A, which means this is about booking a reservation, then go to this agent and book a reservation. Otherwise, it is a generic query, and the user is just asking about some information about a city or some destination. Then go to my another prompt and use travel guide prompt that I have set up earlier. So let's talk about this. So the previous prompt, the first prompt that we saw, this is more of a query profiler, like it takes the user input and, and outputs either A or B based on the query. Now for this prompt, this is more of a travel guide. So it is using the public information and provide you the information about the destination that you're looking for. Now in this case, you can see that I'm using a prompt from a prompt library. I'm not using the prompt right here in the node itself. And I'm also able to select the version, and then I'm also able to select this model. Now, when you use prompt from the prompt library, the model comes with that because we have configured a model with our prompt as well. So the model comes from there. You can select a order and everything, and this message is also basically coming from the prompt library. And you can define these inference configurations and everything. This is basically also comes from your prompt library. So what this prompt node does, it takes the input, which is kind of some information about a city. It basically acts like a travel guide. So if you see the prompt for this, okay, so you are an enthusiastic and knowledgeable travel guide. Your task is to provide accurate and comprehensive information, answer the user's questions, and user's question basically is something which we are capturing in a query variable. So this is the example of a dynamic templates. And we also have to provide this user query, the original query, to this prompt node, plus it will get the information from my conditional node as well. So same goes to the agent. So if the output of this profiler node is A, then it means that the user wants to book a restaurant. So which means, how can I book a restaurant? Because the large language models, they cannot book anything because they just tell you about some information, but they cannot take actions on your behalf. This is what agents are capable of. So this is where agentic AI and all these things are basically going towards, to have this capability in your Gen AI workflow to do real-time things, which your LLM models are not capable of doing. So this is where I'm going to use the agent that we saw earlier. So from here, you can click and select your restaurant reservation agent. And you can also select your version. So you can either select your published version or you can select your test version, right? So test version is basically the default AS, which is always point to the current unpublished version of your agent. But once you publish that, you can use that published version as well. And then that's all from this settings. And finally, the response from the agent goes to the flow output node, and response from this prompt goes to the second flow output node. So this is more or less how you can, stitch multiple components together and build a workflow. Now, one thing to keep in mind with this, when you're using flow service and you are using multi-turn agents, multi-turn conversational agents, this is still in preview. So sometimes you may not get the expected response from this multi-turn agent because this is still in preview, but hopefully things will more stabilize in the future once they will make it as a GA. So once done with all these configurations and you're happy with your changes and everything, the next thing that you can do is actually go and test your flow. So in this case, I have two options here. One is to look for some information about a city, and second is to book a restaurant. And let's see how this flow works. So if I ask my model, basically ask this flow itself that provide me top 5 Asian restaurants in Toronto, right? So let's say I'm visiting Toronto. I don't know like what are the top Asian restaurants. So let's ask this agent if it's capable of providing us. So this is so you see here, this is sometimes a star's uh, unexpected response, because this is supposed to go to uh, my travel agent or my travel guide node, but it goes to my, this time it has gone to the book restaurant one. So let's try this once again. Let me just save it. Fill this. Let's rephrase the question a little bit. So what are the top 5 restaurants in top 5 Asian restaurants? So now you can see that it has gone to my travel guide node. So sometimes you have to play with how you are phrasing your question, and also how you have how well you have defined your prompt. So this is more or less the hit and trial, I would say, exercise to define your prompt properly and then rephrase to make sure that whatever type of whatever the way you phrase your question, your model should be able to understand that. So that's what prompt engineering is. So this is kind of the hit and trial you need to do a little bit when you set up these workflows. So in this case, what was the question? The question was, what are the top 5 Asian restaurants in Toronto? So this is a user is asking for some information, like I'm not actually trying to book a restaurant. So this question is basically received as as my flow input in the flow input node, and then it goes to the profiler. So what profiler did, it took the input, and the output is B. B means the user is asking for some information, like it's not really asking for booking anything. Now it goes to the conditional node, and the conditional node saw that, okay, the input is B, which means I need to send this request to a travel guide node, which is my prompt basically. So the travel guide node got this request from the conditional node, and it generated the output. And this is the output it generated. So these are like 5 Asian restaurants in Toronto, and also gave some travel tips, because this is what we have added in our um, in the prompt message. Like you provide this information, but alongside you also provide some travel tips. So now we know that, okay, these are the top 5 Asian restaurants, right? So I'm just gonna copy this the first restaurant name here. And then I'll ask this a follow-up question. Uh, I would like to book a restaurant in Toronto on March 31st. So now I'm actually asking to book a restaurant. So now you see here, it is asking me a follow-up question. So let's check the trace again. So what happened this time? So we start with the flow input node again. So this is the new follow-up question, or a message, and then the profiler picks up that message, and this time profiler decided that, okay, this is this is basically category A, because the user is asking about something to book a restaurant, right? And then this is received by the conditional node, and now the input is A, which means it goes to my agent this time. So it did not go to the travel guide. This time it has gone to the agent. And now you see this thing called the multi-turn. This is this is an example of we are using multi-turn agents, because it has got one input, but now it's asking for a follow-up question, and based on our agent's configuration, it is asking this follow-up question. So now it's asking, okay, what's the time? Like, what time would you like to book? So let's say 5 p.m. And how many people. So you go back to the show trace again, and this is the same process that's being followed here. So this is 5 p.m. This is multi-turn. Now, if you go back here, you see that this time the flow node did not get updated with 5 p.m., right? So the flow node is still my original request or my message about booking a restaurant. But now we are seeing that this multi-turn conversation, because of this feature, after this first multi-turn conversation, or the response. Now this is the second multi-turn, conversation. So right now for this follow-up question, I said, okay, I want to book restaurant for 5 p.m. And now it is asking another question: how many people? So let's say 6 guests. So I'll have 6 guests and cuisine, say Asian. So now it's asking for a restaurant, and I'm going to provide the restaurant name. I copied over. Now it's looking for a confirmation that just to confirm, we would like to book this restaurant in Toronto on this date, 5 p.m. for 6 people. Uh, say yes, that's correct. So your reservation at this restaurant has been uh, completed or successfully made. Now this thing, let's go to the show trace again. So you see this, we have all these multi-turn conversations going on. This is happening because uh, the agent did not get the answers to all the questions, right? So all the information that we defined as parameters in the agent configuration. So as soon as it got all the information, and then it executed uh, the final, you can say, the response, and then we get that, okay, your reservation is successfully made. Now, if we go back to my agent, let's click in the new tab. So if I try to edit this, and you see we have two action groups here. And if I click on this get reservation, so this is where all these questions were coming from because of all these parameters that we have defined here. Now, I said earlier that you have two agents here. You have two agent groups, sorry. One is to get all the reservation dates and other is to create the reservation. So this final message that you see here, that your reservation at this restaurant has been successfully made. So this is coming from my uh, create reservation action group, because the agent is smart enough to understand, okay, once this action group has completed all its steps and I get all the information, I need to just make a booking, because this is what we have defined in the prompt as well. Like once all the details are collected, you need to create and confirm the reservation. And the create reservation, as I shown earlier, it is using a Lambda function. And the Lambda function is basically responding with a dummy message, like it's not actually making the booking, it's just responding that your booking has been made. But this is where you can replace this with the actual code and use API of some restaurant booking API and make the booking. I mean, it's easier said than done, but this is the workflow in a nutshell. So this is an example of using multi-turn workflow, uh, multi-turn agent with your flow feature or flow service within Amazon Bedrock. So let's go back again. So like I said earlier, if you make any change, you can create a new version of that and you can use that in your app. And you can basically call this workflow in your app as well. You can build this workflow that we have seen here. This is a UI. You can also build it using, I believe, a YAML template as well. So that's also supported. So that's all about how you can create a an end-to-end Gen AI workflow with the support of multi-turn conversational agents, and how you can integrate your prompts and your conditional nodes and your agents and everything in your workflows.